Hello, everybody. This is quite a nice turnout we have today. This is super nice to see, actually. So this is more data, more problems. And I'd like to quickly introduce the idea of why we're doing that and who's involved. And then Ankit is going to take over and give you an overview of the agenda, and then we're going to start real soon with the actual talks. So the idea pretty much is, well, the idea was not Notorious B.I.G., but along the lines of Notorious B.I.G., who figured out really fast that the more money you have, it's actually not going to be all better, but actually you're going to have a lot of issues and problems as well. Probably more so in the ghetto and then the neighborhood that he grew up in, but we kind of believe that something similar applies with big data as well, where kind of the more data you have, it's not necessarily going to be easier. It might actually be harder. So like he back then came up with this graph of scientifically proven by him, where the more money, the more problems. And in a similar vein, we kind of computed this at Cliqz, where more data equals more problems. And that is pretty much, in a nutshell, that's it. We want to create a community, and we want to create kind of a gathering of people who are interested in data privacy, data security, anything related to data and problems. And as the business guy in me would say, probably challenges rather than problems. And that's why we joined forces as well with Mozilla, who we work with together nowadays. And we believe we kind of share lots of common values, and that's why we're hosting it together. So, yeah, Ankit, would you take over and maybe share a few words about Mozilla?
So, thank you all. So, I'm Ankit. It's good to see you all. We actually planned this since like last 1 month, so it's great to see such an audience, so thanks a lot. So Mozilla has been like a leader in open web since the last 15 years, and in a way it has sort of redefined the open internet in many ways. And it actually now stands very firmly with people who actually believe in the same idea, and that's why one of the reasons that Mozilla stands with Cliqz. And to be honest, it's one of the initiatives that we are looking into regarding data privacy. Part of the organization I belong to, it's called the REPS. Mozilla REPS is like a sort of a program for volunteers to gain some official recognition in Mozilla and conduct such events related to different topics related to the open web. So without further ado, I would actually invite JP. But before that, I will actually give an overview of what we have today. So the first two parts are done. So next we'll have Jean Paul, our founder and CTO of Cliqz, who will give this presentation, Unsafe at Any Speed. Then we have Konark and Sam. They will give some more in-depth sort of outlook about some of the problems that we have with more data, and some of the problems that we have related to online tracking. So please stay tuned. We have lots of exciting talks here. Thanks.
Hi. So how many of you know what PowerPoint karaoke is? So PowerPoint karaoke is a sport, competitive sport, where you see the presentation at the same time as you're giving it for the first time. And this is what I'm doing because, as you see, this is not my name. This is my colleague, my co-CEO, and he's sick in bed, so I'm going to give his presentation without having really seen it much before. So let's see how that goes. But I know the story very well, so it should work well. But I really didn't see these things before. You do it like this? Yeah. So when I click you.
In the middle, it's better for the live stream. FYI, we're live streaming this to cliqz.com/meetup. So if you want to send it to any of your friends, hashtag it, whatever. Yeah, hello.
Hi. So we are Cliqz. As Ankit said, we are a company which is invested in by Buddha and Mozilla, as you see below this. About 100 colleagues, mostly engineers. Oh, that's 50%. I think we definitely have more than 50 engineers. 31 nationalities, so we beat everyone in terms of diversity here in Munich. And we are the first browser with built-in search and zero private data about our users. And we will talk a little bit more about what that means. So for those of you who've never seen Cliqz, basically what it is it's combining the two yin and yang of the open internet, which is the browser. That's the tool that allows you to really have an open internet because you do not have any app store or any review process or whatever between content and consumer, and search, which allows you to find that content, because the dirty problem of the open internet is that without search it doesn't make that much sense. For some reason, or because Google was so generous with its search or paid people a lot of money to get their search box, the search never really was combined in the same company as the browser, except when Google Chrome and Google Search obviously merged. And we're trying to fix that a little bit by bringing search and so the navigation and the browser back together where they belong. This is a car. This is the Corvair. What happened with this car is quite interesting, because the car industry and the internet industry are somewhat similar in the sense that the car basically gave people freedom, right? So when you were able to afford a car, you suddenly had freedom. And it turns out that at least the US auto industry decided to give the consumer what they wanted. And what the consumer wanted was a new car every couple of years, big engines, not so much brakes, lots of chrome, because it looks better, you look richer with chrome, and basically followed all of these things pretty much to the limit, until the car, and this is the last car, the car that killed it all, became a technical nightmare, because in order to drive this car and not kill yourself, you need to have very seriously different tire pressure at the back than in the front. Like, we're not talking 0.1 pound per foot-pound, we're talking about like a massive difference, 50%. And if you didn't do it right, you would just crash. And that's what happened with the car. And there's a book by a guy called Ralph Nader who basically looked at the US auto industry and declared it unsafe at any speed. There was zero incentive in the system to protect the user. There was all the incentive were in the system to protect the auto industry, and none was to protect the user. And we think that we've reached a little bit the same status with the web. So we love all the services that the web has to offer, and we certainly are the last one who want to restrict it. I think all of the innovation is absolutely fantastic, and we should never take it away, but somehow we forgot the seat belts and the brakes. And somehow there's a little bit too much weird things that if you go to New York, you suddenly have, this is, I think, Focus Online or something. I mean, it becomes basically unreadable without an ad blocker because of the retargeting. And by the way, because Focus is a sister company, this is not what they want to have either. It's just that the marketplaces have decided that this advertising is more expensive or more valuable to them than something that would look more or less beautiful, and basically destroy the page in the process. Data drives money, right? So if you look at average CPM, or at least average revenue per user per year for any advertising-driven business, the data-driven ads will basically outperform anything else by a factor 10. Like I said, it's PowerPoint karaoke. Like, I'm sure there's some, like, bam. The thing is, we also build an industry that is not trusted, right? And this is a little bit terrible, right? There's a lot of things that I think are becoming clear in 2016 that we never expected, right? The internet was supposed to be this nice place where everyone would trust each other because there would be full transparency, but it turns out not so true. The internet was supposed to be the place where there would be less lies, because you could always go to a search engine and search and say, did Hillary Clinton create ISIS? And the internet would very gladly say, no, that's bullshit. Except it turns out you can pretty much type anything in Google and the internet will say, hell yeah, that's true. You're not alone in believing crazy things. Right? So there's a lot of things that we... I'm sorry? That's maybe good. Is it good? Sorry. Yeah, so I don't know why he had that slide there. But basically there's a lot of information that that make people somewhat uncomfortable when they search the internet, because they suddenly realize there is something behind this that I don't fundamentally understand. Why does this website see that I want to go to New York? How come I get some health warning if Microsoft gets its way saying that maybe you have cancer, 95% sure. Or targeted pregnancy things to a teenage girl, and her father sued until he found out that Target was right. So that happens too. So we did a study in November last year, where we instrumented a couple of 100,000 users that we have at Cliqz, so it's a very small subset of our users, to basically look at the internet from the perspective of the user and see how many % of the pages that they saw contain trackers or third-party trackers that were invisible to the user. And as you can see, there's only 5% which is secure, which, by the way, is probably Google, right? Meaning the biggest spy of them all doesn't spy on itself and doesn't let anyone else spy on them. And so they probably represent the small little chunk there. Most of them are out of control, or a lot of them are basically out of control. This is how many % of your traffic the tracker sees, status 2015, November. This has increased significantly. I'll give you the new number. But to understand this, you have to understand that this is only the third-party view. So this would be the 61% of the pages that Google knows that you went to. That's the number that they would know if you never used a Google product in your life. If you don't have Chrome, you don't have Android, you don't go to search, you don't do anything. This is only third-party stuff. This is Google Analytics. This is Google Tax Services. This is Google Fonts. This is Google AdSense. These are all the pages that you don't know are associated with Google. So obviously the true number is much higher because Google is a large part of the internet. The same goes for Facebook. We know that these numbers have significantly increased over the last year. So Google is probably around 70 now, and Facebook has almost doubled over the last year. So that's not so scary in a sense, because you recognize these names. So you could even, I don't know, some of you are maybe customers, we're definitely users, and it's all fairly okay. Maybe Yahoo is a bit scary because they just got hacked many times and they're being sold to a big telco. This is a bit more scary because these people have significant amounts of your profile. You know, you see on the top right, double pimp. That's, you know, you can imagine what they do, right? And they basically tell you, if you go to their webpage, they tell you they collect data and will sell it and do whatever it takes to increase whatever performance that they want to do. And they're mostly present in porn sites, of course. So this is in our browser. Basically, this is actually our webpage, and we could not even, we had to work very hard to make it safe, because we put a Vimeo video on our support website, and that thing basically brought with it one Google tracker. Like, we really don't want trackers on our website, and yet you just put a little plugin, you put some library, you put something, and you will bring a ton of them with you. Now you could say, well, that's not really much of a problem, that they know that you go to one site or two sites or three sites. Maybe they really, we can believe them when they say there's not your name on it, right? Maybe they don't know who you are. The problem is, it's not really true, because once you put a couple of harmless URLs together, if you know that these belong together, then you know that this person basically has an account at MyFitnessPal, that she's the administrator of some website about Heilpraktiker, and that she has a bank at this bank. And you put them together, you know that it's her. And this person, probably in the data that you can acquire on the web, there's about 60,000 URLs that she visits every year. Not with her name on it, but you can figure it out within 10 minutes. And if she would see it, she would probably have the same feeling that she would have if a place was robbed. No one would steal anything, but they would go through her underwear and her drawers, etc., and she would feel like she needs to move. And that's the feeling that you would get if she would see the home history. This is actually one of my bank accounts. So you have Facebook, Twitter, and Google, really? On my logged in bank account page? Like, really? There's no Twitter tweet thing and on like button or anything, right? This is really done in order for them to know how much money I have, which in this case is not that much. That's good. But it's the only purpose of this is that. It's not some social network, cozy little feeling. Why is there HIV? Why is there 88 trackers on the HIV testing page of the Mayo Clinic? And make no mistake, BlueKai belongs to Oracle, as far as I know. Exalate, which is maybe there, well, it is there, belongs to Nielsen. They try to be everywhere, and they put a tag, so they must have some BlueKai tag thing that says BlueKai 54 means you have AIDS. And you can tag it that if you want, you can buy it from them. And there's no opt-out, because how can you really opt out? Now, I don't know if you've read this, but this is something that is concerning. Facebook is also targeting people who don't use Facebook. How can they? Well, they own my bank. That's how they can do it. They don't need your name. Right? Google changes privacy policy. That's a slide that Marc forgot. I think 15 times over the last 6 years. It never got more restricted, by the way. So you cannot opt out. If you have extension and add-ons, you can buy this data freely on the market. We have not yet seen an extension that is safe, except ours. It's not safe. They probably steal all of your URLs and sell it. You probably heard about Web of Trust, which was discovered end of last year to be selling all of the data of all of their users. Antivirus companies always sell the data. They perform man-in-the-middle attack, which we have big discussions about, because we cannot make our users safe if they have some version of Kaspersky, because it performs a man-in-the-middle attack on all of our users. And you get, I have no idea what he was trying to do here. Lots of numbers, sometimes spikes. No, but basically this is what a profile looks like, right? It's a bunch of timestamp and a bunch of URLs, because this way you're almost guaranteed to not break any privacy rules in any countries of the world. But obviously you know that what's grayed out is the name of the user. You know exactly that. There's no way to do this unless the ID up there is the user himself. And then whatever happens before and after, it's basically you have identified the user. Wow. That's a hard one. What is this? That's the user, probably. Is it? Yeah. Again, then I'm a bit blackout, then it's really bad. Basically, what we do at Cliqz, we are a big data company, so don't make any mistakes. We do need data to create a search engine. It's impossible to do it without. But what we are obsessed about and trying to find the best solution is how to make sure that the data about the user stays on the client, and the massive amount of data that we collect in the server can never, ever, ever be connected to any user. And there's only one solution to that, and I hope he has it on the other. No, he doesn't. There's only one way to do this, is that you cannot allow to have any items that is being sent to carry any personalized identify information about the user that viewed it. So we need to filter a lot of URLs, your Dropbox hashes and what have you. And we need to make sure that there's never, ever any session. I'm sure others will reinforce that point. So I have no idea when this presentation is over, but this is basically what happens when you don't pay attention to anything. And this is typically when industries arise, they tend to create a lot of pollution, a lot of side effects, a lot of security issues. When you try to fix it, it doesn't mean to make it less good. On the contrary, we want to make faster cars. We want to give them super brakes. And we want to make sure that the internet becomes a better internet, but as a user agent. So we represent the user and not the search engine, the operating system, or something of that sort. And I guess that's it. That was a good karaoke. We do the question afterwards. Q&A now? Not after? If you have any questions. But I'm sure my colleagues will talk about super interesting things.
Maybe two simple, obvious questions.
Yeah.
Don't make money with data.
Yeah.
How do you earn your money? And
Well,
just because you're here now,
Yeah.
question I could ask to Mozilla and to the other. How do we know we can trust it?
Yeah, so maybe let me start with the second one because it's a lot easier. So this is also one of the reasons I believe that it's, well, it's many reasons why it's great to have Mozilla as an investor, I mean, obviously. But we are truly open source. So you can check the code that sends the data back. We do regularly security audit. I think we're going to start another one with Princeton University. So it is an open system in a way. So you can observe in the browser we even have, I mean, not many people use it, but you can actually see all the data traffic that we send back to us, and you can audit it yourself to see if that would sort of breach your privacy or something like this. So that part, I think, is the best way to do it is to be completely open, because you cannot expect a normal naive users to be able to verify trust, right? So you have to rely on other people and brand names like Mozilla and the fact that an open source community will scrutinize you. I think that's the only good answer for that. The money part is, we are live broadcasting, so I don't want to reveal too many secrets to Google or anything, but let me put it this way, is Google made 99% of its money in the first 10 years of its existence without ever breaching people's privacy. It didn't need to, because if you get the query and you know that someone is looking for a specific widget, to deliver an advertising about this widget does not breach anyone's privacy, because you don't know who is looking for the widget. You just know, here, this is something, if you want widget, maybe you can click on that. And then only if you do this did the widget seller realize, oh, no, I know someone. It's only later that they started this tracking across internet, because if you're a public company and if you go public, you need to have growth. And growth, you have to find it somewhere. And so what we're going to do is basically go back to that original business model, that the client knows that you are looking for widget. We don't need to have a profile on you on the server saying, this guy needs widget. Your client is there for that. You have local storage. It's like your history, for example, stays in your browser. We don't need to have it. So we can do personalization because your history is on the browser. We have a CPU on your computer. It can do filtering. It can do stuff. We don't need to go back to this world of Google where everything needs to be in the server and everything needs to be in Mountain View and everything needs to be, because then I can run machine learning a bit better. So we keep the data at the edge. If you're looking for scientific stuff, you can look at computing at the edge. So trying to push the computation where the data is so that you don't centralize all the data and then you have all sorts of issues that, from secret services to your own curiosity. I don't know if it's fair. Excellent. Let's keep them coming. No. So we don't have, well, you can download the browser or the extension. We don't have any registration, and there's the telemetry. So we separate, if you want really details, there's no user ID. We don't. We're trying to get rid of them even when they are created implicitly, because sometimes, if your clock is a little bit off, that could be used as a user ID, which is typically used by trackers, and we try to get rid of all of that stuff. So there's really no registration, no. Yes. So on the server side, you could simplify it by saying it's a gigantic popularity contest between all of the users, in a sense. I give you a German example. If you type SPIE, the sad truth is the global answer to that is Spielaffe, not Spiegel. But once that result comes to you in your browser, we can easily look at your history and say that's a Spiegel guy and not a Spielaffe guy. But we don't need to know that at the server side. If that simplified. Right? Oh. I'm sorry? Well, as far as, the search will be strangely German. So we don't have a Chinese index at the moment. So let me think of, so first of all, the Chinese internet is a little people have a lot of misconceptions. So first of all, China has probably the most interesting variety of search engine and browsers that you can see anywhere in the world. Because Google not being there, it creates a lot more, let's say, experimentation, for sure. The problem obviously is the government, but the government basically will randomize certain DNS requests that you do. So if you want to go to something and they don't like you to go there, they will send you some stupid IP address that doesn't work. And of course, Cliqz will be just as affected as anything else. For this, we have a sister company in Asia which does not use DNS and is widely very, very successful. Because they only mess up with DNS, really. Otherwise, it's the same. No? So we have, by default, we don't think it's a great idea to display porn results, because if you do a popularity contest, you can type pretty much any letter of the alphabet and there will be a good porn site for that. So we have a very, I guess, well-trained porn filter. So it never gives you porn result by default unless you're really looking for porn. So if I think 90% of the result from the server are porn, then we say, well, we know what you know what you're doing, we know what you're doing, just go ahead. But we will never show you porn by mistake, or almost never. We have an interesting little feature that if you go to a porn site, we assume you don't want to save that in your history, so we put you in automatic, we call it forget mode, which is the automatic private mode, by default. So but we don't have any child protection, so we would not make a claim, look, you can make a few switches and then you will never see porn, so we don't. So that you mean? So we have a lot of anti-phishing technology. Maybe we'll talk about it, maybe not. But because of the data set that we have a unique ability to detect phishing. If you're talking about just security like viruses, etc., usually we rely on more open services like, well, I don't know if they're open, but Google, has this search Bloom filter. So this Bloom filter of web pages that are known to distribute malware, etc. Because of anti-tracking, obviously we block or randomize or render useless, depending a little bit on the case. I mean, there's a reason why many porn sites can afford incredible bandwidth that it takes to deliver video for free. So obviously they're into somewhat nasty practices, and third parties can help mitigate some of that. But we never really thought about protecting the user in that particular way. No, I mean, we never really thought about this. I don't know how many children are using Cliqz. We know that the oldest Cliqz user is 86, that we know, since last week. But the youngest we don't know. No, so we never really looked into that particular problem. So I don't know what to answer.
Thanks. That's the other question we often can ask them later. Thanks, guys.
Hi, good evening, everybody. Really excited to be here at the first More Data, More Problems. Thank you. I'm going to talk about how data, I think, is becoming a Frankenstein's monster because, as you've already seen, data collection is ubiquitous, it's invisible, and it's being collected at enormous amounts, right? And the major problem is people have less and less control over the data that is being collected, both by individuals who are generating that data, companies who are collecting that data, and people who are trading that data. So this is one of the articles. Well, it's an article from 2001, but I came across it recently. And it's a hard fact about cookies that before cookies, web was essentially private, right? But since cookies have been adopted to web, the space is capable of enormous amount of monitoring that is possible. And most likely, the monitoring or tracking of the users is being done by one of the marketing technologies that we have. Analytics, ad brokers, insight providers, direct targeting of the users, and etc. This landscape is actually from 2011. I would take a quick guess, if anybody wants to guess. How many companies do you think? In 2011, there were only 100 companies like BlueSky, Oracle, Google Analytics. How many companies do you think in 2016 this landscape has? Any random guess? Anyone? Well, the world is not that bad right now, but maybe soon. As of 2016, there are about 3,800 companies who are collecting data. This data could be anything in terms of analytics, in terms of recommendation, in terms of insights, in terms of just page visits. Now, we all carry a mobile phone. We all surf websites. We all have some kind of smartwatch or fitness tracker. Some of us are more advanced, have smart Bluetooth brushes, smart cups, connected cars, and all of these devices, all of these apps are generating enormous amount of data, which could be very, very private to you, which could be actually your behavior towards the things you see. And this data is being collected by a lot of first parties, but also by a lot of third parties, which is a big problematic area. And the other area is a lot of these tracking, as you saw in the earlier slides, is invisible, right? You as a user of an app do not really realize who else is collecting that data. And once that data is out of your machine, out of your device, you've lost control of it. You don't know how it's going to be used by any other company. Let's focus on these 4 individual elements. Anyone sitting here could just open a network monitor in their browser and just surf few sites, and you could have similar elements getting emitted from your browser. Let's say there are 4 events. One is my Twitter profile page. One is somebody searching for pizza near Zillerstrasse. One is a query done HIV test Munich. Some analytics data about page loads, and somebody buying something online, right? Now, these 4 data points in isolation are not of that big a harm, right? But the moment you put a timestamp and a UID to them, you exactly know that these 5 elements belong to the same person, right? And even if you just drill down a bit further, for example, just take a look at the last event here. If you actually go and open this URL, you would actually see who this user was, right? And an interesting part to this particular URL itself is this number after the receipt that you see is actually a sequential number. So I was actually able to do a random sequence on this and get detail of all the other people who are visiting this site, right? So even this page has a third-party tracker that collects the data, and that third party could actually use the same thing against your company itself. So you're putting your users at a big, big privacy risk. As a website owner, right, I want to increase engagement on my website. I want to target more audience. I want to increase the engagement. I want to provide social logins, social share buttons, right? So based on digital trends, I'm most likely to use one of these most popular services, right? But while you're rejoicing to increase the engagement on the website, you're also trading your users to these third parties. Just to recap, these 4 data points. These are actually 4 data points going to the same third party on different websites. And if you think that it's a practice by very few shady websites that they do not care about users' data, take a look at this number. It's 78% of page loads in Germany are actually sending data to at least one third parties with respect to privacy. This is one of the data points that we have published in one of the studies we did earlier last year. So you want to use data, right? As data practitioners, I am hoping nobody wants to intentionally track users, right? We want to collect data to analyze data points, right? We do not explicitly want to track people, right? So this could very well be a side effect that I wanted to do analytics, but I'm also learning more about the user, right? And why is that side effect present? Well, primarily because most of the data collection system, if not all, rely on server-side aggregation by the user, right? What that means is when the records reach your server, they have to be linked together. And to link them together, there needs to be an ID attached to it. The ID could be an explicit ID, an implicit ID, a short-term ID, a long-term ID. It could even be an ID just basis your network fingerprinting. And we'll see in the further examples that record linkage will always produce side effects. No matter which company you are, what kind of analytics you do, there will be privacy side effects as long as the server-side aggregation of data is being done on users. We'll take a quick example on Google Analytics, not because we have something against Google. I think this example is good because most of us sitting here understand the use cases of Google Analytics, like counting unique users, sessions over pages. Second, Google actually does takes pretty good care while collecting data to sanitize the URLs. It does not have cookies. So it does take care of a bit more than the other trackers about users' privacy, right? But we'll see, even though when GA takes care of the user's privacy, there are privacy side effects that are bound to happen. A user visits a page, wire.com. It has a Google Analytics call. It sends a lot of data, but let's just focus on two data points right now, the IP address and the viewport resolution, along with the timestamp. Then the user visits another web page, eBay Clientside. It has IP, it has a viewport resolution, the same. Now the user visits a Twitter page. It's a public Twitter page. Anybody could visit it. And it is by the same user because it has the same IP and the same viewport resolution. And finally, the user, during the same time frame, visits this page, analytics.twitter.com. This page is only accessible after you log in. So first of all, as you saw in other banking pages and other pages, even this is behind a login screen, and yet there is a Google Analytics call. What is more dangerous over here is the URL itself contains the username. And a user can only access this page when the user is logged in. So now, not only did it carry back home my PII, but because the records are linkable on the server side, it gives the potential to a tracker to actually go back in history and correlate where all I have been on the web. And when you're talking about a tracker with a presence of 44% page loads, this is a huge chunk. Now, we don't know whether Google Analytics actually uses the viewport resolution to track the users. Does it even track users across domain or not, or across accounts or not? But what we are sure of is it uses some sort of UID, some sort of identifier to actually track users on the back end. If you take a look at the first table, you see there are 4 visits on wire.com, the same page, without any viewport resolution. Assuming the user is not using a proxy, the IP will reach the Google Analytics backend, right? Now, based on the first table, Google Analytics cannot resolve whether these are 4 different people or one person visiting the page 4 times, right? To solve this basic use case, Google Analytics has to attach another variable, another value, which will be treated as UID. And in this case, only then you can say there were 4 visits by 3 unique visitors, right? The problem statement was they wanted to count uniques, which they're doing pretty well. But on the other hand, along with counting uniques, they're also compromising the user's privacy, right? Because there are PIIs attached to it. User data, like any coin, has two sides. One, if we use it responsibly, if we gather it responsibly, it is used for good purposes. But if we are not careful, it can have serious consequences. Remember this slide that JP showed in the first presentation, right? Trackers in Germany. And remember the use case I showed of Google Analytics. Now for a moment, just replace Google Analytics by choice of your tracker in this, right? And see who all on the web can actually get similar information. More on that, you are putting users to greater risk because you do not know who has access to the same data, right? Data breaches or hacks are not unheard of, right? So imagine somebody having access to the same data set. They can potentially learn a lot about a user. And all you wanted to do was count uniques, right? There was no intention of you as a company to track a user. What you wanted to do was do analytics, do uniques, do goal completions, right? But what you're putting over here is users at great risk. Well, the last point could be very relevant when the government comes knocking on your door. And if you give them the data, you have UIDs in the data, and they'll be able to not just extract one event, but the complete history of the user on the web. So what can we as technologists, developers, or hackers do, right? We at Cliqz are already paying a lot of emphasis on how we collect data socially responsibly. But we all over here work with data in somewhat sense, right? So what can we all do? Well, the obvious solution is stop the data collection altogether. Let's just stop collecting data. We don't need data. That would be good, right? But if you stop collecting data, companies who already have your data will still rule. They have your data, what they need. What will stop is the innovation that is needed on the internet. Companies like Cliqz or companies like here in Vaira would not exist because there is no data. What we need is a bit of change in mindset. When Cliqz wanted to become a search engine or have great features like anti-tracking, anti-phishing, we faced similar problems. To make a product, you need data, right? But the problem that we saw was server-side aggregation. When you are carrying back home a user ID to do server-side aggregation, you will run into problems of privacy. So what at Cliqz we did was, we said, let's move the server-side aggregation to client-side aggregation. Client-side aggregation meaning moving the computation to the browsers. So let's go back to the same example of counting uniques. On the left side, you will see the Google Analytics backend and the browser of the user. On the right side, you would see the Cliqz approach. We call Cliqz Green Tracker. So you visit the same page, wire.com. It loads the third-party tracking script. Google Analytics will generate an event with the URL and the same two values, IP and the viewport resolution. In terms of Cliqz, what we will do is we will not yet generate any event that we need to send back. We will say, let's generate an event, visit, and a unique visit. And then we will check in the state of the browser whether this user has visited this page before or not. So the state was empty earlier, so now we will put hash of the URL. I'll come later to why we do the hash of the URL, and the timestamp inside the state object. And what we will send back are two events in our case. One is the visit, and the other unique visit. There is no UID attached to any of the events that we send. And if we send it via the proxy network that we have, we do not even have the capability of doing network-level fingerprinting. But in case of Google Analytics, you will still send the URL and the combination of the same values. We still have the same data. We do not have the same data, but we are still able to do the same use case of counting uniques, right? Let's say the user visits the page again. Now what will happen is the third-party tracking script loads, Google generates another event. But in case of Cliqz, what will happen is we will check in the local state whether this user has visited this page or not. If yes, then we will not send the unique visit count. We will only send the visit count. In this case, there's a question because Cliqz is a browser, so you might wonder that Cliqz has the ability to do local storage and local computation because you're a browser. But in HTML5, there is a possibility because you have local storage and post APIs. So all this client-side aggregation, irrespective of you, whether you're a website or a browser, you are still able to do. So in this case, what we'll do is we will not send the unique visit. We will only send the visit. So on the Cliqz backend, these are the events that you would see: 2 visits and 1 unique visit. And now you can run the same counting uniques job, and you will have the same result. Counting uniques is trivial, right? You guys might have really difficult, complex things that you want to do, and probably that's why might be collecting user IDs. But Cliqz, based on this philosophy of doing client-side aggregation, has been able to build a full-fledged search engine, anti-phishing, anti-tracking, news recommendation, and a lot of other products. And none of these is a trivial task. They are fairly complex things that needs to be done. But it's totally possible to do them via client-side aggregation. What needs to change is the mindset with which we collect the data. There are few general guidelines. I mean, each project has more stricter rules and checks before collecting data, but there are some general guidelines that we follow in Cliqz. Sessions or users are forbidden in Cliqz. If you have to do data collection, there cannot be any session. Meaning you cannot send any value back with the data that will make 2 records linkable. We do not send everything. Although being a browser, we see everything happening on the URL bar, which makes us sit in a position where we could potentially send everything. But Cliqz does not send everything. We run, before sending anything back home, we would run a set of complex heuristics on the client side itself, sanitize, mask the data before sending. And only we send aggregated data, which is capped at a day or an hour level. Now, while sending data, we do not attach any explicit ID. We do not send data in a batch because it could potentially become an implicit ID for you. And we have a set of proxy network through which we route the data before sending back home, so that even at the network fingerprint, at the network level, we cannot have any IDs where the data is coming from for the user. To further prove our point that this is a totally possible use case, the client-side aggregation is totally possible in this world, we actually have a small prototype that does what Google Analytics does. It can count unique visits for you. It can count returning customers, goal completions, cross-site correlation, inside click-throughs, visits, time page per user, the bread and butter of Google Analytics. And we have a prototype of it in less than 200 lines, which basically does everything without sending a user ID back home. Feel free to try it. We are open to understand more of your use cases to see how we can use client-side aggregation more further to make the data collection more safer for the users. At the end, I would just like to say that at Cliqz, we believe it is totally possible to produce great features for the web. We've seen it with the search engine. We've seen it with anti-phishing and anti-tracking. And all of you over here can do similar features if you just change the mindset a bit and just think about it for a while of moving from server-side to client-side aggregation. Thank you. Questions? Well, it's kind of tricky because when you're using a first party, you usually opt in to give your data, right? The first problem is the unintentional tracking that the third parties could do. Currently, if you treat Cliqz as a first party when you're using the browser, we put strong emphasis that even though we are a first party in terms of browser, we are not collecting everything about you, right? So as a first party, it is totally possible for even the first parties to solve their use cases. Probably, if not all, then a lot of the use cases that they do could be solved. But as I said earlier, you really need to change the mindset. And it is something that you cannot just do overnight that, okay, I'm going to move my server-side aggregation to client-side aggregation. There are a lot of other thoughts that you need to put in. But once you get it right, I think it is fairly possible to do all the use cases that you might have. Sorry? And DuckDuck. Well, primary difference is we have our own search index, which DuckDuckGo does not have, as far as I'm correct. So it's essentially using a backend to serve your search queries. And whatever backend is being used, Bing or Google, whatever is being used, could stop being used, right? But Cliqz, as a company, has its own search index. So we are the ones who are powering the search in the browser itself. So it's not like an API that connects to a third-party search engine.
Can you maybe elaborate a bit on the difference in terms of how do they stop the advertising and what terms is it affected by?
Well, as far as I can understand, advertising is money, right? So even if whatever search engine they're using at the backend, they do serve ads, but I'm sure even to serve ads, you have to share some kind of PII with the ad provider or whatever it is. And even if you say that you're providing a small identifier as an IP, we've already seen what damages can be done by just carrying back home an IP or other small parameter. So even though they say the search is private, but I'm not really sure that the ads would be. Sorry.
You're talking about the browser, right?
Yeah.
Nowadays, the browser is collected on a mobile phone. The application sends something and they many applications serve ads, etc.
So we do have a Cliqz mobile browser as well, which follows the same principle. Your mobile browser or your mobile application has the capabilities of doing storage, right? So the whole idea is of moving your computations on the user's device, right? So your mobile app can also do computations. It has storage, right? So I don't see a reason why you need to send. I don't see a reason in today's scenario where if you explicitly want to track somebody, you should send user IDs back home. You could very well do it on your devices itself. Not really, but I think that's a good point. I think it would be a nice idea to actually write a small prototype like we did for Google Analytics to have it like a mobile SDK or something. Totally looking forward to it. If you have some free time, I would love to hack it just after the conference as well, just after the meetup. Open to it.
So hi everyone, I'm Sam from Cliqz as well. So I'm a developer on anti-tracking software, so I'm going to kind of cover a lot of the stuff that's been said before, but go a bit more in depth about how our anti-tracking works and how it prevents this kind of data collection that we've seen. So as we've seen, basically user profiles are the currency of the internet. They're being used to make money in advertising and lots of other places, and companies are kind of fighting for access to this information. So they all want to be in the page when it's loaded so they can get a bit of data. And in general, the privacy of the users is ignored, and there's no transparency in this process. Most people don't know what is being loaded when they load the page. And we also see in a lot of cases that when if you try to protect yourself, it breaks lots of functionality of the internet. So how does this work? If I visit some website, like a news site, I may get advertising, this kind of thing. But what's really happening behind here? Well, in this case, there's over 20 different companies. I'm sending data to them in order that they decide to show me this particular ad. There's content recommendation systems, there's analytics and social widgets. Why are these there? Well, developers are putting them there. Likewise, if I go do online shopping, it's the same thing. It's the same guys. It's analytics, ad tech, social. even if I just go to some random blog that looks to be completely plain, I find the same things. Okay. And as JP showed before, even in online banking, we find that I've been logged in, I just logged out, and there's another ad tech pixel there. So these guys are following me on the web and collecting my data. And this is the same as we saw before. Only 5% of the time you're actually not having any third-party trackers in the page. And this could be okay. These companies are providing tools and they have high reach, but if they're responsible, it's not necessarily a problem. But they're using this server-side aggregation. So as we saw, if I'm browsing the web, I visit one site, and the site says, okay, you need to load this widget, load this script from some third party. And my browser will send a cookie, a fingerprint, and an IP address will be sent. So just so they can say there's a UID and they visited this site. Likewise, I visit another site, and the same thing happens. So then they have the UID and the 2 sites I visited. What have they learned? I visited these 2 sites. But if you extrapolate this over a day, a month, a year of browsing, they learn a lot more. So how do we know that people are doing this? Well, we can actually just test this theory. We could record out a request going out of the browser, record some metadata about what was sent, and then we can take some data points that we think might be user IDs and see how many requests we can link together with a particular UID. So, for example, if we had some requests to double-click and we saw some cookie, we might say have some set of requests that were linked by this bit of data. Then we can look again at the request and say, can I see any of the pages I visited in the data that was sent? And then I can build the session that could theoretically be collected by this third party. So we did some tests with this. So if we take a default browser configuration and we crawled 900 pages, just so with a default Firefox install, using a couple of tools like Selenium to automate the process and a man-in-the-middle proxy to record the requests. What do we see? Well, double-click, so this is Google, had a cookie which linked 650 of these pages. Again, Google are there with another 500, Facebook. So the first one not using a cookie, like we saw before, is Google Analytics, but they have this viewport resolution. And this goes on. So within the top 7, there's at least a third of my history which has gone to one of these tracking companies. So you might say, it seems cookies are part of the problem. If I turn off third-party cookies, that might be some kind of opt-out. So we can run the test again. So this time, double-click have a few less pages. But now they can combine these values to basically make something unique. So this is the time zone and viewpoint resolution. And then we see the same things again. So it's got a little better, but still I'm being tracked over a significant proportion of my history. The other problem is if I turn off third-party cookies, part of the web breaks. So if I use third-party payment providers, if I want to buy something here using PayPal or Amazon, I get an error message. It just says, something's gone wrong. It's probably because you're blocking third-party cookies. So how do I protect myself from this? Just using the settings available in the browser is not enough. So maybe I need an extension that can block these requests. There's quite a few different things available. You can use an ad blocker with some privacy list or some specific products aimed at protecting against tracking, like Disconnect, Ghostery, or Privacy Badger. But they have some, well, we think they have some shortcomings. So in general, they're too coarse-grained because instead of looking for this data that's linking the request, they're just going to block the whole request. And this is going to break things. Likewise, they're manually curated, so they're always chasing the trackers. When a new company appears or a new a new product, they have to find it, and they have to add it to their block list. So in general, this means that they'll have more false positives and more false negatives. There are also some further issues with blocking in general. So this will break the web. So if a developer puts certain things in a web page and then you're blocking half of it, it's obvious it's not going to turn out exactly as the developer intended. And generally, we're starting to see more of an arms race in that publishers are trying to block you from accessing their content if you're blocking their advertising. As also, these have incentives in different directions. So the users who turn on ad blocking see such a faster web that they don't want to go back, and the costs of this are hidden to them. On the other side, the publishers are fighting over fewer and fewer users who are actually able to see advertising, and this is making the tracking more invasive. And they don't really have any other options here, because no one is selling advertising without tracking. Finally, there's a lot of power in the hands of the people coming up with these block lists. So if I am able to update a block list that's then pushed to 30% of the web browsers, there's lots of possibilities I could do just to block some random competitor. So what Cliqz have done, we've come up with a solution that can protect your privacy but without blocking. So the idea behind this is that we're going to remove these unique values that are being used to link. So these UIDs, we're going to remove that from requests instead of blocking them. And the way we do that is we detect uniqueness using a crowdsource data. So we can share the data between users and say if lots of other users saw the same value, then it's a safe thing. It can't be used to link your browsing profile. We also tackle this issue with third-party cookies by always blocking them until there's a user interaction with an element for this third party. So, for example, in that last case, if I have this payment page and I want to, so I load the page blocking all the third-party cookies, but then when I want to actually initiate a PayPal payment, for example, I click on the button, and that says that now I will temporarily allow this cookie. So an example of this, the other part, which is deciding what is a UID and what is not. So if I go to a page and there's a request to this tracker, and there's a load of different values put in this data, how do I know what is a UID and what is not? So first we split it into all the different parts. Some things I can evaluate just locally on the client without talking to anyone else. So if it's the first time I've seen a value, then it's not linking anything. So I can say this first one is safe because it's a new value to me. Also, if they're very short values, there's not enough entropy there for it to be a useful UID. If there's only 10 possible values for it, then it can only distinguish 10 different types of user. Finally, if the value is changing a lot, so I see several different values for it, then it's also no use as a user ID. But what if none of these apply? Then I need a bit more information to know if it's a UID or not. So what I can do is we can look at see if other people saw this value. So this top one is a common screen resolution. So it turns out that if I look at the data, lots of other people saw this, so therefore I can say that's safe. It's reached decorum. And this also works for things that you wouldn't be able to objectively evaluate. For example, this second one, it looks a bit suspicious, but we can then evaluate from the data whether it's safe or not. Ones that are not safe, we can then replace with a new value. So at the moment in the Cliqz browser, we replace these values with a standard placeholder, so all Cliqz users appear as one user to the trackers. So in order to work out this quorum, we need to collect some data for that. So again, we need to design privacy into this system, because we're basically looking at all the data that would be being sent to the trackers. If we just collected that as is, this would be a privacy violation. So firstly, in order to count the number of users, we can rate limit. So we can say each client will only send one message per tracker per hour. This means that within a 1 hour bucket, we can count the number of users. Secondly, we can hash all the elements of the tuple, so we don't actually need to know the real value sent. We just need to know if it's the same as someone else saw. So we just hash it with a one-way hash function, and then we don't know what it was. And finally, as Konark mentioned, there's this human proxy network, which we can send the data through, so we don't know where it came from. So we just receive the data at our backend, but we don't know the IP address of the user who sent it. So this system we've been running for over a year, and all other users have had it since April. We also run the same thing on our mobile browsers, and we get data from 8 million page loads daily, which we use to generate these stats you saw. And we block 300 million third-party cookies per day, so only 4% are actually needed in order for the web to work properly. Then 10 million requests are modified a day, which turns out to be 30% of pages loaded need something to be modified, so someone is trying to send a user ID out. We also measure how much we break things on the web, and we find it's lower than most other privacy-related extensions you can use. So to conclude, it is possible to protect yourself from the kind of tracking we've been talking about, and it doesn't have to cost your usability of the web. Mobile is an issue. So there was a question about mobile apps. We can't do anything about that. They are tracking you using device IDs and this kind of thing, and at the moment there's no way to deal with that. There's also problems with browser defaults. For example, on iOS, if I open a link from an email or something, it will open in Safari, where I don't have the same tracking protection. We can only protect when you're in the actual Cliqz browser. And finally, a couple of things for the developer community to think about, like Konark mentioned. We really need to evaluate the privacy properties of the products we're using. All of these trackers are being put in websites because they offer some utility, but are we thinking about the consequences of doing that? And I think it's a good idea to move to self-hosted options. So this constrains the extent of the session that can be gathered, or using client-side aggregation tools. So thank you for listening. You can read more about anti-tracking on our blog, or contact me and Twitter and everything. Thanks. Questions?
Systems already learned how to detect that I'm using an ad block. Right?
Mm-hmm.
They please turn this ad block off and allow us to serve you ads. So there's probably a way that they will figure out this something, right?
Yes, that's true. Yes, so in the case of the anti-ad blockers, it depends on how we respond to that. So I think there's data that the sites that are putting up these anti-ad blocker walls get a very high bounce rate. So there is a strong economic disincentive to do this. Basically, with our system, because we're not blocking, it's not blocking ads. So for them, if they allow us in, then it's still beneficial for them to have our users. So it depends how these things line up. with this system, it's we're trying to incentivize to move away from server-side aggregation, and hopefully it incentivizes to not, the sites not to be nasty to our users. Question? Yeah, so this is quite interesting. So in one of the early prototypes of this system, instead of putting the fixed value for these, we were just putting some random data. And we got some nice attention for that. So because I think there were some spreadsheets that were automatically generated that were meant to be like 1 page long, and now they were several hundred. And they spoke to us, and we've changed how we deal with it, but I don't know if it's so bad if these are the people we're pissing off. Yes, so yep, so with our anti-tracking system, we don't touch anything that's first party. So if you do it, and this includes subdomains on the same general domain. So if you have like an analytics.yourdomain site, this won't be touched by our system. To come to the other point, so I mentioned self-hosting your analytics, I think is a good idea. There's a couple of systems available for that. But yeah, this could be much richer than it is. The thing is, the big players have dominated so much with such high quality tools that then it's difficult to make the decision to do it yourself, and that's.
So when we did the test, by mistake we randomized stuff because, well, by mistake I don't know, but we randomized stuff because it's fun to randomize stuff, and it was interesting to see the reaction from the industry. So we had a lot of big German companies that complained, and then they found out that they were tracking users by mistake because their subcontractors were tracking the user on their behalf, but often sharing the same ID across all of their customers. And so basically they're stealing data from you. Don't believe the ad tech industry is working for you. It's not. Yeah, but that's what they thought. So they thought that they were doing. Yeah, so they were doing tracking conversion. So they were doing tracking. They were tracking conversion in the shop, and they thought that the third party was tracking their conversion, but they were tracking conversion on a global basis across all of their competitors, and that's not so good, right? Because then you have a big third party who knows everything about conversion in widgets. And they're going to crash you. They don't care. So you should be always careful when you involve a third party. Not only because of privacy of the user, they're going to screw you just as much as they screw the user. They're not working for you. They're giving you something for free or for very, very cheap. So, I know it's hard, but don't trust third parties. They're not working for you.
Our browser uses the Firefox one, Firefox User Agent.
So I can't tell whether it's Cliqz or Firefox. Oh, because most of the user are an extension anyway on Firefox. The user agent is supposed to be Firefox.
Yeah, the majority of users use just an extension in Firefox, and then the subset use our own fork. So in this case we mentioned, one of the things, so one of the companies said we'd rather have no data from you than this tampered data. So actually when we do modify, we send an extra header that says this is Cliqz anti-tracking, so they can filter this out before it lands on their servers. But this would be the third party doing that, so it means they have to set up a system where the third party tells the third party to then pop up the notice. So there basically would have to be a collusion that the first party would know that third party's tracking and they're okay with it, and they'd want to block our users. This one over here. Sorry, which user data? No, so our search backend. No, we don't do that. So our search backend returns the same results for every request, and there's no user ID sent. No, so that's the whole concept behind this privacy by design, is that all the data we collect, every message that arrives at us is independent. It cannot be linked with anything else, and all PII should be scrubbed on the client. So in this case, so if we were hacked, there was a data leak, or if the government asked for data, we wouldn't be able to find any users in our data. Or if there was one rogue message that leaked something, it couldn't be connected to any other message. So we're minimizing our risk in this case. Yeah, so if they want, they can route the traffic through their own domains. Yeah. Mm-hmm. Yeah. So if the first party really wants to do this tracking, then they can obviously manage it in various different ways. One of the main issues, particularly with ad tech, is that the publishers don't actually know what's being loaded in their pages. So there's actually companies who will try to tell you this. So if I have some site with some ads in, I can pay some other company to tell me what ads are actually being shown to my users, because they don't actually know. So I think it's less likely that the site owners themselves would be complicit in this process.
So regarding tracking devices using their IP address, I was wondering how you guys are going to handle the IPv6 IP addresses, because as far as I understand it, these addresses are mostly unique in most scenarios.
Yeah, so we're working on some prototypes to build a kind of mini Tor network of our users. So basically when the request to third parties that we know to be trackers, we can route your request via someone else and thus hide your IP address.
There's one question actually from the live stream.
So he asked, I'm not sure whether that's Konark or Sam, but he asked, how do you deal with client-side abusing of that tracking? And he names examples of spoofing values, paths, conversion rates, etc. Do you understand that question? Do you want to ask?
Can I read the question? So, well, I think the question, I'll repeat the question once again. So how do you deal with client-side abusing of that tracking, spoofing values, path, conversion rates, etc.? I can mention from the perspective of Cliqz that because we do not, the data that we collect does not have any identifier. So it is a challenge for us at our backend to know whether this traffic is real or not. The user we are getting, the data we are getting is fake or not. That's why we have this complex set of proxy network that we use to detect fake traffic and yet not compromise users' privacy. I think that's the question where it leads to. So, yeah.
Thanks. I would like to wrap this up for now. First of all, thank you, Sam, for answering all these questions. Two more things. First of all, today you've heard a lot of Cliqzers, and that was by design because we thought it was a bit easier now to start off with, like, where we are sure that the speakers are going to show off, you know, and we know what the presentation is going to be. But ideally, the presentations are going to come from you. So if you want to talk about anything related to this topic, it would be super nice if you just shoot an email to me or Ankit or Sam, anybody at Cliqz. So that's usually the first name at the last name. Please don't send us spam. But usually the first name at the at Cliqz.com, sorry. And then, yeah, if you want to talk about anything, please shoot an email, first of all. Second of all, we have lots of swag from both Mozilla and Cliqz back there. So that's going to be T-shirts, stickers, pins, tattoos, like this. Cool. And like wristbands and anything. So just, yeah, grab whatever you want. And we don't want to take it back home. So please grab it. And then, yeah, thanks for the team for making this thing happen. Thanks, Mozilla. Thanks, Cliqz. So that was Madi, Ankit, Alexei, JP, obviously, Sam, Konark, Alexandra, and I hope I haven't forgotten anybody. Did I? I think that was all. And me. So thanks for being here today. And you're obviously happy to stay as long as you want to, grab more beer, Coke, water. Again, we don't want to bring it back home. And